Why is Cadonix interesting from an electrical design perspective? Let's talk about that next. All right, so let's talk about Cadonix. But before we get into the details, it's important to understand the context here. So we're really talking about the design of electrical systems, which carry signals between electronic endpoints and delivers power to them so they can run. We're not really talking about EE systems architecture, which is figuring out what software functions go on to which ECUs, electronic endpoints, as well as mapping out what bandwidth you're going to be using on your network, right? So there's that whole activity, figuring out what goes where. This really isn't that today. We're talking more about this, figuring out what that system looks like. So with Cadonix, it's interesting because it is a cloud-based solution. So you can develop schematics and diagrams and lay out what the system looks like in detail. You can also develop basically a 2.5D kind of routing through your vehicle or other type of product to get wire links and things like that. So that's what the tool does. But it's really interesting because it is all cloud-based. So let's talk about the implications of Cadonix being a cloud-based solution. So obviously you have this core definition of your electrical system in the cloud, right? Many different representations from a diagram, schematic, and even a routing perspective. So that's important that you have that. So as your company, maybe the OEM can connect in and people can access that model from anywhere, right? They can be around the world. They can use almost any device. They don't have to be on a VPN. They can access it from anywhere. But the other interesting aspect of this, and what I found really compelling, is that other people outside your company, when you give them access, they can also, connect in and work and develop that model, any of those different aspects. So you can bring in specialists, you can bring in analysts, and there are lots of different roles that are involved in the development of an electrical system. And not all of them are going to be working within your company. So why exactly is that a big deal? Because when you look at the electrical system design process, especially in the automotive industry, it's a fundamentally a federated process. You see different activities in the development process split out to many different suppliers and contractors and specialists, and it's almost guaranteed that all those folks that are going to be working on this system, they're not going to be within your company. There's going to be at least some portion of the folks that participate and contribute here are not going to be working for your company. So you really do need to have them collaborate and contribute and correspond and be able to participate in some way. Now, you could do that in the old way, which is emails and models, which terribly ineffective because you get on different versions. You can also try and do a VPN, like give them access to an on-premise system, but this could be such a dynamic situation where you want to bring on a specialist for a day or two and then ramp them off. Getting an IT group to grant that access and then turn it off a couple days later, very difficult. And do you get the timing right? Do you give them access to only the things they need to see? So that's the compelling thing about this being a cloud solution, is that you can turn on and off access very, very quickly. And it's very easy. Again, the whole idea that you can access it from anywhere on any device at any time is really powerful, especially when you get into processes that are more federated across many different companies. So overall, Cadonix is a pretty powerful solution. There's lots of capabilities there in terms of both designing it, performing some analyses, planning out the manufacturing process. A lot of detail there, a lot of mature capability, but What I see as a big difference is this cloud inherent nature of the solution. And that can make a really big difference for the development of these systems, which are inherently federated. So that's it. Take care. Talk soon.